lot of it on the test, but there's no guarantee that you're going to see a little bit of it. You know, one of my suggestions when it comes to geometry, at least right off the bat, would be to ensure that you have everything that you need memorized as far as, you know, formulas and equations and stuff like that go, because there is a ton to memorize. Lastly, we have a lot of that stuff on our equation sheet, our equation guide. I know a lot of you using our course right now maybe have missed it, but if you go to our resources page, the equation guide that we have is super duper thorough. You'll notice in the geometry section, it's even more thorough. So I think it would be wise when you get to geometry to maybe use that a little bit, and that'll allow you to get some things memorized that you need to know. So today I want to start off by doing some stuff with triangles. I think triangles is a very big part and tricky part of geometry on the GMAT. So we're going to start with a triangle question right off the bat. And we may get into some right triangles as well, but for now, let's just start with a couple simple triangle questions. Like always, I'll give everyone about 2 minutes, and then we will you can put your answer in the chat box. Someone just told me this should be a rates webinar. You know what, everyone? You're right. Today is supposed to be a rates webinar. Thank you for reminding me. Geometry was on my mind because I was going to do geometry. So we will do rates. I do have a newborn here at home, so that probably have also affected my brain. So geometry will come, everyone. We will not do that question. We will get into rates today. As far as rates are concerned, we will be getting through all of the kind of different segments of rates, and we're going to do distant problems here today. I want to start off with average rates, and then I want to get into some more challenging ones. The good news is, like geometry, there's a lot that can be memorized from rates, although you wouldn't realize it. There are a decent number of rate questions that I'm going to want you to be able to recognize based on look and appearance and what they're asking. One of those is definitely average rates. As you know, average rates use a very specific formula, and we're going to be going through all the different formulas. There's at least as much as we can get through today to talk about that. So thank you for that reminder. If we're back on track. Here is the first question I want you to do. And as I said, put everything in the chat box. I want to know what you're getting as your answer. I want to know when you're getting your answer, stuff like that. Okay, so everyone start. I'll give you about 2 minutes. Okay, so it's about 2 minutes. The good news is, looks like most of you got the right answer here. There was a few of you who did not. So the first thing I want to talk about is what the trap is here. Now, in my opinion, the trap in this question, for those of you who are not familiar with average rates yet, is the fact that when you try to get the average, you are saying to yourself, well, I'm going to take each rate, I'm going to add it together, and because there are 2 rates, I'm going to divide by 2. So that's 14 over 2, that's 7. That's not correct. So that is a trap answer. The other thing to recognize, or if you know this, that the formula for average speed is average is equal to total, which I'll just put with a T, distance over total time. Now, in general, speed is equal to distance over time, so it's no shock that average speed is equivalent to total distance over total time. So what we like to do is we like to set up charts. Now, the chart is not changing what the math is behind the problem or anything like that. It's simply putting you in a place where you feel comfortable and organized with your information. I think sometimes a downfall that we have on this test is we're doing everything so rushed that everything becomes disorganized. So any opportunity you have to organize your information, the better. Notice I put 2 rows here because there's 2 actions taking place. We have going to and coming from. And then we just start filling in. So the first thing is we see that going to, Melissa's going 4 miles per hour. And in fact, we don't even have to write MPH. We know that that's what it's in. Coming from, she's going 10. Now, where it gets interesting is when we have to fill in more of the chart. Now, what some people mistakenly do is they'll say, well, I'm going to say time is T and T in both boxes. Well, the issue with that is that we don't know what the time is, and nor do we know whether or not the time is the same. But we do know that the distances going to and from are the same distances. So you have 2 options. One option is to use a variable. Another option is to use a strategic real number. And we can do this both ways. So I'll show you first what we would do if we were to use variables. We would say D and D is the distance. We would say D over 4 is time 1, D over 10 is time 2. So then it's just a matter of adding fractions together. We would say 2D over D over 4 plus D over 10. Get common denominators, that would be 20, so you're multiplying this by 5 over 5, this by 2 over 2. 2D becomes 5D plus 2D, so that's 7D over 20. Flip and multiply. D's cancel. We get 40 over 7, which as you can see is 5 and 5/7. Now, if you wanted to, you could have been strategic and said, well, I'm going to make D20 and D20. Now, the reason I'm going to do that, I mean, that's the common denominator, so you know that our times strategically will be pretty clean. That's a 5, that's a 2, so total distance over total time is 40 over 7. Honestly, it doesn't matter which way you go here. It's up to you. Some people like to plug there, some people don't. So it's kind of a thing that you have to kind of make a decision on. And you don't have to make it right away, but you can, based on what the problem is asking, you can make that decision. I generally stick with variables because I don't like to put added thought or pressure into coming up with what number to use. So I just find it too easy to use variables. The reality is the math is the exact same regardless of what you're doing. So keep that in mind. Okay, so let's move on. I want to do a question that's actually sounds really, really similar to this, but it's not. Now, of course, I'm not going to tell anyone what the problem is. I just want to see what people do here. So why don't you take a look at this. and then we can certainly talk about it. So I'll give everyone another 2 minutes or so. Okay, so it was about 2 minutes. This is called a round trip question, and there are 2 ways to deal with it. I prefer a certain way. I'm sure some of you prefer a certain way. But I think either way, you're going to find that using the formula that D1 equals D2 is very efficient. So the first thing you want to do here is make your chart again. We notice, and this sounds kind of like an average rate question, but it's not, which you'll see because they're not asking for average speed. So we know Jack's going to a place. We know he's coming from a place. 2 is 40. From is 60. And here's the interesting thing. We're given that there was a total of 2 hours traveling. So what we can do strategically is we can say, well, I'm going to make one of my times t, And then my other one, 2 minus t, because t is the total. So if we know this is made up of 2 times, 2 minus t would represent the other time. And no, it doesn't matter which box you put t or 2 minus t, it will all work out. Distance is 40t. Distance is 120 minus 60t. Then we set up our formula, 40t equals 120 minus 60t. 100t equals 120. T is 120 over 100, which reduces to 6 over 5. Now, this is where you have to make sure you don't get too lost. This represents the time. You then can plug it into either distance box you want, because remember, the distances are the same, to get the distance going one way. So we have 40 times 6 over 5, gives us 48 miles. Make sure that you do not put A as an answer, which was nice. No one here put A. That's great to see, because the total distance is 96 miles. So again, hopefully for those of you who have studied distance problems, you recognized right away what we were dealing with, and you knew right off the bat that we were working with a round trip question, and you knew exactly how to deal with that. So I want to get into some slightly harder questions with some different types of rates. So what I want to do is, again, give everyone 2 minutes, but so far, so good it looks like with what we've been able to get through here. So again, another 2 minutes for everyone, and then we'll go from there. Okay, so that was about 2 minutes here. This one is a converging distance problem. Now, converging means you're going towards each other. There's also such a thing as a diverging problem, where you're going away from each other. Either way, in these problems, you're dealing with a formula that is d1 plus d2 equals total distance. Now, there are other ways to do this. Some people add the rates together. It's a similar process, but I really like doing it this way. Again, I'm all about being systematic on this test, so that's the name of the game. So I know it's converging. I say, all right, there's my formula. I'm going and setting up my chart. Now, in the chart, we have rate, time, distance. We have our two boats, and we start filling in. Now, we see that they're 100 miles apart. That's going to represent the total distance. So with that said, we have a rate for x, which is 10 miles per hour faster. Actually, it's just one boat is traveling 10 miles per hour faster. So we can choose whichever one we want to be faster. We'll make y faster in this case, so we'll call that x plus 10. Now, they're both going for 2 hours, so we put 2 and 2 here, because that's the time they're both traveling for. Multiply across, we get 2x. We get 2x plus 20. So 2x plus 20 equals 100. 4x is 80. Now the math becomes simple. X is 20, and that is our value for x. It's asking us to sum them. There's 20 there. There is 30 here. Sum them together, you get a grand total of 50. Okay, so that is a pretty simple converging question. I want to do some more of these. I want to show different variations of these. We talk about a lot of this in our curriculum, but remember, all rate questions, like an algebra question, can have variations. The unknowns can change. Notice in this previous question, the unknown was the rate. Now I'm going to show you one where the unknown is the time. So again, 2 minutes for everyone, and then we'll talk about this. Okay, so it's about 2 minutes there. This is a great problem because we're dealing with a new unknown. As you read through the question, the first thing you want to be thinking about is this a converging? Obviously, we know it is just because I told everyone right off on the outset here. But it's obvious to see that it is too, just based on kind of looking through it. Well, I lost my whiteboard here. So you can tell that it is just based on looking through it, essentially. So we know that D1 plus D2 is still going to be total distance. Now remember here, they're 245 miles apart, so that is going to represent the total distance. We have our chart, so we are going to fill in. Now what do we have? We have train A, and then we have train B. We have a rate, we have a time, we have a distance once again. Train A is going 50 miles per hour. Train B is going 60. Now here's where things get interesting. We're given that train A starts at noon and train B starts at 12:30. Now, based on that, we're in a situation where we need to make sure we're correctly allocating the extra time to the correct train. Since train A leaves earlier, we can call train A's time. Remember, we don't know what the time is of either train till they meet. We can call it T plus 1/2. Make sure you use 1/2 and not 30 minutes because our rate is in miles per hour. We always need our units to match. Train B is T, so we end up getting 50T plus 25 and then 60T here. Plug into our final formula. 50T plus 60T is 110. Now it starts to get easy. 110T plus 25 equals 245. 110T equals 220. T is 2 hours. Now, we're not out of the woods yet. We need to now plug this back in. You can choose to plug it into the top box, which is train A, or you can choose to plug in to the bottom box, which is train B. It's going to make more sense to plug into the box that has less going on, because if you plug it into the top box, you have to add the extra half an hour. If you forget to do that, you may put 2 p.m. as your answer. As you can see, 12:30 plus 2 hours is 2:30 p.m. Okay, so hopefully that was okay for everyone. You're using the skills I'm teaching you. You're using your D1 plus D2 formula. You're filling in your chart, et cetera, et cetera, et cetera. So I want to do one more question. This is going to be a data sufficiency look at some of these. And, you know, you can see data sufficiency with these. I think most of you are used to seeing them in problem solving. But, you know, data sufficiency does exist, so we have to be, you know, ready to see that. I'll give everyone a shot here. And 2 minutes, then we'll talk about this, and we can kind of wrap up on this question here. Okay, so it's about 2 minutes. This is a good question because it's testing you on things we already talked about. You know, we know that D1 plus D2 is total distance. And right off the bat, they're giving us the total distance. They're saying it's 2 miles, which is great. So we know that if we can figure out some components of this chart, we'll be good to go. Now, it probably didn't take most of you long to determine that, you know what, statement 1 on its own is not enough, statement 2 on its own is not enough. So based on that, we are going to kind of go and look at these two statements together and see what we can come up with. So we have Paul and then we have Steve. Well, first thing we know about Paul and Steve is that Paul's rate is twice Steve's rate. So Paul would be 2R, Steve would be R. So that's something. The other thing we know is that they started simultaneously. So we know that their times have to be the same. So really what we end up with is that we have two variables here. If we can get a value for one of those variables, that would be great. So we get that in statement 2. We say had Steve run the entire 2 miles on his own, he would have completed the 2 miles in 20 minutes. So that means the rate of Steve, distance over time, would be 2 miles per 20 minutes or 1 mile per 10 minutes. Because it's data sufficiency, we don't have to go any further. We know that the answer here is C. So hopefully this was pretty good for everybody. I think rates is one of those topics that should be everyone's bread and butter. And I'm confident that it will be, presuming that, you know, everyone puts in the time and effort and energy and all that stuff here to learn this stuff. As always, if anyone needs anything between now and next week, feel free to reach out to me. I'm at Jeff@Target Test Prep. And all of you who are studying hard for the GMAT, just, you know, stay positive and keep working your butt off. It will definitely pay off. So looking forward to chatting with everyone next week, and have a good rest of your day. See you guys.